Alright, let's look at the homework 8.2, problem number 2. Alright, so first thing I would do is I'm going to divide this equation through by 4. So that we have x is equal to y squared over 4 plus 5. Alright? And then, so I'm going to do the integration with respect to y. So I want to see a corresponding y value. So if x equals 5, so plug it in. So you have a 20 is equal to y squared plus 20. 20 cancel out. So it looks like a y equals 0. So this corresponds to y equals 0. Right? If it's 13, so let's see, if you plug in 13, 4 times 13 would be 52. So 52 is equal to y squared plus 20. So we can just subtract 20 to get 32 is equal to y squared. Then we can take the square root of both sides. So it's going to be a plus or minus square root of 32, right? And I'm going to just do a 0 to a positive value, so positive square root of 32, right? So this gives you y equals square root of 32. All right, then we can set up an integral. So integral s is going to be, all right, so we're going to have 2 pi as usual. And then you're going from 0 to square root of 32, right? Then since it's a rotation about the x-axis, then radius is going to be the y value. So I'm going to put y here. Then arc length formula, so it's a square root of 1 plus, right? If you take the derivative of x with respect to y, you would get, let's say, put 2 in front, so it's 2y over 4. Derivative of 5 is 0. So it's just going to be y over 2, right? Because you can cancel 2 and 4. Alright, so if you square that, you're going to get, let's see, y squared over 4. Alright, then you have a dy. Alright, so we're going to do the substitution. Let u be, I'm going to call this expression inside the square root u. So 1 plus y squared over 4. Right? So we take the derivative of u with respect to y. And this is going to give you 2y over 4. Again, so we're going to get the y over 2. Alright, so we can take the reciprocal of both sides. So we have a dy over du is equal to 2 over y. Alright, then we can multiply both sides by du to isolate dy. So it's going to be 2 du over y. Alright. And then lower limit and upper limit. So y is going from 0 to square root of 32. Alright. If you convert it, so it's going to be, u is going to be, plug in 0, it's going to be 1. Right? Plug in square root of 32, so it's going to be 32 divided by 4, and then it's going to be 8 plus 1, so it's going to be 9. Alright? So this is going to be, 2 pi is already there, but we're going from 1 to 9. Alright, I'm going to leave y here. Then you have a square root of u. dy, we just found out to be 2 du over y. Alright, so we can cancel y here and a y there. And then we can clean it up a little bit. So we have 2 here, so I'm going to combine with 2 pi. So you're going to have 4 pi. Then you have an integral from 1 to 9. And the square root of u, I'm going to write it as u to the 1/2 power with respect to u. All right? So you have a full pi, just a constant. Antiderivative is add 1 to the power, so 3/2 power. Divide by 3/2 is equivalent to multiply by 2/3. And then you're going from 1 to 9. All right? So I'm going to combine the constant together. So it's going to be 8 pi over 3. So I already took care of that and took care of that. Then we plug in 9. All right? 9 to the 1/2 power would be 3, and cube that, 27, minus plugging 1, it's going to be 1, right? So that's going to be 26. All right, so what's that? It's a 26 times 8, right? So you're going to have 48 and 16, so 208. So you have a 208 pi over 3. All right. So that is the surface area. All right. So let's type it in. All right. We got 208 pi over 3. All right. Submit for testing. All right. It came back and looks like we got this one correctly. All right. That's it. I hope that this was clear.